Alright, today we're going to look at solving radical and rational exponent equations. And just to get some vocabulary out of the way, we have the nth root of a. And in this expression here, n is known as the index. The radical sign is known as the radical, the radical sign. And the a is known as the radicand. Right? And what we can do is we can actually take radicals and switch them into numbers with rational exponents. So for example, the square root of 5 is the same thing as 5 to the 1/2. And the cubed root of 7 to the 6th power is the same thing as 7 to the 6th thirds. So what we did here is there's an imaginary 2 there, we brought that around, and this was raised to the first power, we made it 5 to the 1/2. Here we have the cubed root of 7 to the 6th power, the 3 came around, went underneath the 6, and we got rid of the radical sign. Right, and we can do vice versa. So here we have 8 to the 3/4, that's the same thing as the 4th root of 8 cubed, and 3 to the 1/2, that's the same thing as just the square root of 3. Alright, so let's take a look at the problem. The square root of 2x plus 5 minus 1 is equal to x. And this problem contains a radical, so what we want to do first is we want to isolate the radical term. And by the radical term, I mean just the part that's under the radical. So if we want to isolate this, it means we have to get rid of the minus 1. So we're going to add 1 to both sides, and now we have the square root of 2x plus 5 is equal to x plus 1. Alright, so we're done. Step 2, you're going to raise each side of the equation by the power of the index. The index here is a 2. It's understood to be a 2. Oh, actually we don't need that. So we're going to raise both sides to the second power, and what's going to happen is that we're going to eliminate this radical sign. So now we have the square root of 2x plus 5 squared is equal to x plus 1 squared. And the radical goes away, so we have 2x plus 5 is equal to an x plus 1 squared. I'm going to FOIL that. It's x squared plus a 2x plus a 1. From here, I'm going to bring these terms over to the right side. We're going to set our equation equal to 0 and solve from there. Alright, so I went through and I subtracted my 2x and subtracted my 5 because I want to set this equal to 0, and we get 0 is equal to x squared minus 4. Now x squared minus 4 can be factored into x plus 2 and x minus 2, and now you get two solutions, 2 and negative 2. What you want to do now is, it's especially important with square roots, but you want to check both of these solutions to see if they work. Alright, so when I checked my work, I did x equals 2 in the red here. You get the square root of 9 minus 1 is 3 minus 1, which is 2. It does indeed check. And for x equals negative 2, I did it in the purple. You end up getting negative 4 plus 5, which is 1. The square root of 1 is 1. 1 minus 1 definitely does not equal 2. And what I'll do is I'll show you a graph of this function here, and I'll show you what it looks like. Alright, so now if you take a look at this function, you can see that it only crosses the x-axis at positive 2. It doesn't cross at negative 2, right? So we only have one solution. Alright, let's take a look at another example. We have the quantity 3x plus 1 to the 3/2 plus 64 is equal to 0. And just like before, we want to isolate the term that contains the rational exponent. So here's the rational exponent. So we want to isolate this and get rid of that 64, so we're left with 3x plus 1 to the 3/2 is equal to negative 64. Alright, now we're going to raise each side of the equation to the reciprocal of the exponent. So we're going to raise each side of the equation to the 2/3 power. By raising each side to the reciprocal power, if you remember, when you have powers to powers, you multiply them. So 3/2 raised to the 2/3 is the same thing as 3x plus 1 to the 6/6, which is just 1. So now we've eliminated this rational exponent, and we're left with just 3x plus 1 is equal to negative 64 to the 2/3. Alright, so I continued my algebra. The left side stayed the same. The right side, just like I showed you in the very first slide, if we have negative 64 to the 2/3, I can change that to the cubed root of negative 64 squared. The cubed root of negative 64 is just negative 4, so now we have negative 4 squared. And remember to do that inside your parentheses. You get a positive 16, and then it's just solving a linear equation. You get x is equal to 5. Right. When I checked my work, I plugged 5 back into my equation here, and I get 15 plus 1, which is 16. 16 to the 3/2 which is 4 cubed. You get 64 plus 64. That definitely doesn't equal 0. So what that means is I actually have no solutions. When I graph this, it shouldn't cross the x-axis, and I'll show you a graph. Alright, here you can see an example of the graph, and if I zoom in here, it's going to cross the y-axis at 64. But you can see it definitely doesn't cross the x-axis, and we're done. One final problem you might run into is a situation like this one where if you can't really isolate the radical because you have them on both sides. You can move the 1 over there, but it doesn't help you that much. If this is the case, what you're going to want to do is just square both sides so that at least we eliminate this radical. Alright, so what I've done is I've squared both sides and eliminated this radical, so now I have just x plus 5. The problem is we have the square root of 3x minus 8 plus 1 squared, so I have to FOIL that, so I got to write it 2 times and FOIL it, and we're left with 3x minus 8 plus 2 times the square root of 3x minus 8 plus a 1. I moved the 3x, the minus 8, and the plus 1 over to the right side, so I was left with just the 2 times the square root of 3x minus 8 is equal to negative 2x plus 12. Divided both sides by 2, and now, once we're here, we're actually exactly where we were in the very first, the first example. You just square both sides, which I've done right here, and you eliminate that last radical. And now you're going to solve this equation like you would solve any other quadratic. You can factor it, you get x minus 11 times x minus 4, and you get 2 solutions, 11 and 4, and we'll check both of those. Alright, so what I've done is I went through and I checked my 11 down here, and you end up getting 6 is equal to 4, which is not possible, so 11 is not a solution. And then up here I checked my 4, and that indeed did work. Alright, so if I were to graph this, it would cross my x-axis at 4.